Welcome back, innovators. Let's get right into it today. You know that awful, sinking feeling in the pit of your stomach during those massive, high-stress deployment days? Yeah, we've all been there. You've been building and coding for months, right? And then, just when it's time to launch, the whole system crashes. It is completely exhausting. Well, in today's explainer, we're going to look at how to permanently eliminate those bottlenecks and build true, unstoppable momentum. To pull this off, we're leaning into TRIZ. And to help us out, our lead innovation catalyst, our brilliant navigator right here, is mapping out a core truth for us. Innovation isn't some random eureka moment. It's actually a highly repeatable architectural discipline. It uses systematic discovery to solve really complex contradictions. Basically, it proves that we can bridge the gap between abstract ideas and practical execution. We can literally engineer the friction right out of our systems, zero luck required.
If you're ready to stop relying on luck and start mastering systematic discovery, hit that subscribe button to join the Idea Mechanics team. And don't forget to ring the notification bell so you're the first to see our next innovation breakdown. We want to build this culture with you. Drop a comment below and tell us which TRIZ principle or tech challenge we should tackle next.
Okay, let's dive straight into the deep end. Are you still stuck in that exhausting trial and error trap? Because traditionally in tech, we kind of just accept idle time and stop-and-go work periods as totally normal. We build these massive batches of code for weeks, sometimes months, only to watch the system buckle under the weight of it all during a highly stressful deployment. It's a vicious cycle that just burns out developers and completely frustrates end users.
Which brings us to Section 1, the idle downtime trap. The real root of the issue is this batch and queue mentality. As our navigator is highlighting here, waiting weeks to deploy large batches inherently creates massive bottlenecks. When you try to integrate huge amounts of code all at once, you're pretty much guaranteeing severe integration conflicts, and that leads to incredibly long, painful testing cycles. Think about it. You're effectively hitting pause on your entire operation just to release something, and that pause, that is exactly where the danger lives.
Moving on to Section 2, TRIZ Principle 20 Explained.
Enter TRIZ Principle 20, which is continuity of useful action. This principle is a total game changer. It dictates that a system should operate continuously, entirely without idle time or interruptions. We need to completely eliminate all unproductive or intermittent actions. The goal is to have all parts of the system working at full capacity all the time. So, true innovation means we systematically rip the pause button right out of our delivery pipeline.
Let's see how in Section 3, batches to unstoppable flow.
This brilliantly illustrates the mindset shift we need. On the left side, we have the old way, trial and error, batch and queue, agonizingly waiting for massive release windows. But look at the right side, the TRIZ way. This is all about continuous operation. It asks a really vital question. How can we eliminate all unproductive actions so every part of the system works at full capacity? We literally have to abandon the batch mentality completely to get rid of that idle downtime.
This takes us to Section 4, Architecting CI/CD Pipelines. So how do we actually do this? We architect this continuous flow through continuous integration and continuous deployment, what we all know as CI/CD. Just look at this automated process our expert is pointing out. Instead of pausing everything to release, developers frequently commit their code to a shared repository. That's step 1. And that instantly triggers a pipeline where the code is automatically built, automatically tested, and then deployed straight to a staging or production environment. We've completely replaced the giant, risky batch deployment with small, incremental, automated changes. And the result? Your software is always releasable. I mean, that is the holy grail of software delivery, right? By continuously integrating these small changes, you ensure the software is never just sitting there idle in a broken state waiting for a fix. This vastly improves both your delivery speed and your overall system reliability. You have successfully engineered that dangerous pause right out of the system.
Which leads us to Section 5, Continuous Real-Time Monitoring.
Now, continuous delivery is only the first half of the equation. To truly master Principle 20, we need operational continuity too. Think about it. If we only check our IT infrastructure's health intermittently, or worse, after a crash has already happened, we are allowing the system to sit idle in a degraded state. We absolutely have to eliminate those diagnostic blind spots. By continuously monitoring key metrics like CPU usage, memory consumption, and response times, teams can proactively detect and diagnose problems long before they ever impact our end users.
This creates proactive, nonstop feedback.
By applying Principle 20 to our monitoring, we engineer systems that track their own health flawlessly and continuously. This continuous flow of health data provides essential, real-time feedback directly back to the development and operations teams. It creates this powerful loop that systematically improves reliability and performance over time, making absolutely sure the systems are always performing their useful function.
Bringing it all together in Section 6, your continuous ecosystem.
So what is the crucial takeaway here? Pauses are the enemies of digital scale. True innovation isn't just about building a shiny new product. It's about aggressively applying Principle 20 to systematically remove friction from how that product is delivered and maintained. We abandon batch deployments. We engineer 24/7 continuous pipelines. We make absolutely sure that our delivery and our monitoring never ever sleep.
So, I want to leave you with a challenge today. Take a hard look at the workflows, the code bases, or the server architectures you are managing right now. Where are your operations suffering from those stop-and-go bottlenecks? How can you apply Principle 20 today to eliminate that idle time and introduce continuous momentum? Remember, engineering a frictionless pipeline isn't a matter of luck. It's a repeatable skill. Identify your friction points, drop your thoughts in the comments, and let's engineer your continuous ecosystem together.